Signal Sciences secures the most important web applications, APIs, and microservices of the world's leading companies. Protecting over 7,500 applications and 150 billion production requests per week, Signal Sciences Next-Gen WAF and RASP help companies increase security and maintain site reliability without sacrificing velocity, all at the lowest total cost of ownership. Signal Sciences patented technology protects any application against any attack with integrations into any DevOps toolchain. Signal Sciences, demand more from your WAF. Learn more at securityweekly.com/Signal Sciences. By connecting to your code repository, Accurix generates a topology across your full stack to reveal risks so that you can harden your architecture. It also scans code for violations against compliance and security standards to enforce best practices. In addition, Accurix develops threat models using vulnerability feeds, IAM privileges, and other data to predict potential breach paths. Learn how easy it is to get started with Accurix at securityweekly.com/Accurix. Discover a simple way to secure your app without the need for a full security team. With trusted software, simply drag and drop your app and let the ML-enabled smart security work. Get it back fully protected within a couple of minutes. With 50 years of security expertise, Erdetto protects over 5 billion devices and applications for some of the world's best-known brands. Change the world one app at a time. To download the white paper on how to address endpoint security in mobile apps, visit securityweekly.com/Erdetto.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by Matt Alderman and John Kinsella. Visit securityweekly.com/webcast to see what we have coming up. Learn how to create and run a conference from some of the geniuses behind Layer 8 Conference and Wild West Hackin' Fest on August 19th. Our next technical training on August 27th will teach you about Boothole, SIGRED, and SM Bleed, the best practices to prioritize and remediate now. Plus, you can always visit securityweekly.com/on-demand to view our previously recorded webcasts. And we have to definitely thank Caesar again for going through a live demo without running into any flaws. So speaking of flaws, which we have quite a few to cover in web and other protocols today, I first want to start off with, John, you highlighted an article about bug bounty and Microsoft's spending there. What caught your eye there?
I thought that was sort of fun, right? It's we earlier this year we had a few episodes where we were sort of chewing the fat on bug bounties in general. I think we still are. It's an interesting space, but it was interesting to actually see. One of the questions we were talking about is what do you, how big of that budget do you make? Is it actually, do you get good bang in the buck? How do you go down this path? And what some other startups have been talking about. Well, what does that bug bounty look like? How do you assign values, to things and stuff like that? So it was interesting to see Microsoft publish numbers on, how much they paid, what they're paying, and then sort of let you start thinking about, is this a good thing or bad, right? Because one of the thoughts that came out of there, so we're looking basically, I think Microsoft said 3x increase in payments over 18 to 19. So that's a pretty good chunk of change. That was up in the millions, 13 million, I believe.
Yeah, just under 7 million. Yeah.
And then the second part in there, which was interesting to me, was like, okay, if you start paying a lot for these bounties, the good guys are going to realize they can make enough money being an independent hired gun versus joining a company. And is that a good or bad thing? So it was, good read, not too long, sort of gives you a chance to head scratch and think about the space and how you want to participate in it.
Yeah, a couple interesting numbers I calculated just quickly is the average bounty paid was just under $42,000. And the biggest one, as it shows on the slide, is $200,000, right? So to your point, John, you could start to make a living. I mean, 42,000 is probably still a little light for certain people in certain parts of the country. If you're in California, you're probably not living off of 42,000. But you are starting to see some interesting average payouts. So I think it is interesting of how sufficient can you be as an independent researcher in some of these bug bounty programs.
Yeah, but realize if you just do that, you'd have to live in a cheaper part of the world. But if you're able to pull off a 40K hit, or payment, I should say, 3-4 times a year. Mm-hmm. I don't know how that's taxed, but that's not too bad.
Oh, I'm sure you're a 1099 or something. So Uncle Sam's going to come looking for the money if you're in the States.
It's a good time to think about moving to Singapore or somewhere else that doesn't have income tax. So yeah.
It is, and it is a good point there on both on the economics of are you the bounty hunter, because there's the average, but there's also the median, because a couple of really big payouts, really good findings can really skew that average, and suddenly you're back down into just like a few $1,000 or $2,000 payouts, which can still be respectable, but you're just going to need a lot more of those in volume. And then I think part of also too what this article was even calling out is that is $14 million the best investment for improving security? And on the one hand, it is a great thing to embrace the community, make sure you have a good vulnerability reporting program. And I can see it also too, I think I would lean more towards if you're protecting legacy systems, there's probably just bugs that need to be cleaned up. But $14 million could also be put to perhaps less exciting work, but that sort of the builder versus breaker, that builder work in the sense of, well, what if we went and actually killed off a vulnerability class, something like, I'm just going to go to the web-oriented bounties and say, rewrite our front end into React and never worry about having cross-site scripting bugs anymore. Or probably more in Microsoft land, something with just having all of their builds go making sure they're being fuzzed and finding vulnerabilities that way. So there's definitely some trade-offs there to think about and what the economics are, both on the rewarding as well as the hunting side.
But if I think about Microsoft for a second, some of the legacy stuff they have, it'd be a lot more expensive to rewrite like the base operating system, probably, than what they're spending in a bug bounty program. So it's probably worth the investment.
That one you're probably right, because we don't have an example this week, but the last couple of weeks we had an example, I think in Win32k, and what was the one that was an 18-year-old, the DNS? I think that was an 18-year-old bug in Windows or something like that. So yes, the point very well made that it's going to be pretty hard to go re-architect legacy systems for sure.
What I was going to say, quick in there, you fired all sorts of neurons on me on that. So realize, Matt, they are actually rewriting parts of the OS in Rust.
They are, but there's still a lot of legacy historical stuff still under the covers. Yeah. We've seen a lot of issues with DLLs and other things. To rewrite it all would be very, very expensive. Now, I get it. They constantly rewrite pieces, but there's also still a lot of inherited pieces from some of those legacy environments, and that gets difficult, John.
Yeah. And speaking of legacy as well as multiple-year-old bugs, something came out this morning. Man, I forgot about it. We didn't get into the notes. I should have put it in, but there was a bug that Microsoft had for 2 years that they knew about that they didn't patch until last patch Tuesday. So still lots of work to be done there. And I'm not picking on Microsoft. We just happened to mention that. And then, a final parting thought on that, Mike. I think 14 million, if they really wanted to, I think that just about covers your and my salary for a year. So what do you think?
Yeah, pretty much. So yeah, in between episodes, we have Tuesday through Friday is free. So give us a call, Microsoft. But actually, so I'm going to use, John, I'm going to roll back a little bit. You mentioned like rewriting areas in Rust. And I know, for example, Mozilla has been actually adopting Rust in a lot of its, browser infrastructure. And I do have one article about the Amazon, the S3 client being written in Go. And Go and Rust are two, as well as Swift, which we'll get to a little bit later, but these are more modern languages that tend to be a lot more memory safe and killing off classes of vulns, which I think are a good thing, obviously. But one of the things I wanted to highlight here, a researcher from Google highlighted a couple basically crypto mistakes. These aren't earth-shattering in the sense that all of your data in the S3 buckets is now worrisome, but pointing out that even with something like Go, a modern language that is memory safe, you still get to, as a developer, introduce new and different types of bugs. In this case, the different type of bug was some of the nuances of implementing crypto and misusing modes, or being able to shift between, in this case, like a CBC mode into a basically go back from GCM, which is an authenticating encryption integrity protection, to CBC, which is basically, if you've seen, for those of you who are familiar with this, you've seen the classic images of the Linux Penguin, or basically other images that are encrypted with something like, I'm actually going to EBC. I get my modes mixed up, but basically saying that crypto mistakes can happen, the modes can leak original information if you can switch between them and compare ciphertext, essentially, which is what this research was demonstrating, and showing how to retrieve the original plain text, and even pointing out some problems with just the misuse of MD5 in modern systems. So mostly what I want to get there is great research, really interesting attention to detail in the use of crypto in what we could still say are good modern programming languages, modern programming architectures.
Yeah, I thought that was a fun find, as you mentioned. Good, sort of digging down in there. But what you in the notes, and actually they did in their posts, mentioned memory safe languages such as Go. And I was like, hang on a second, is Go really memory safe? Because I've done a pretty good amount of Go coding. I'm pretty fond of it. Did a little Googling around, and while the language itself is safe, relatively speaking, what's interesting is, back to our build of materials, and I think we're going to talk about this in here as well in a different way, but if you start using libraries which are compiled by CGO, you're now looking at a C program which is not memory safe. So there's an interesting little boundary in there between, what is and what isn't. So long story short, don't be too trusting of your code. And I guess Go actually turns off ASLR and some things like that because they claim they are memory safe. So just keep on your toes. Don't just presume it is.
Absolutely, and it's one of those things that Java and JNI has had a way to call into C functions, and it's hard for all these languages to say we do everything when they don't, because they perhaps don't have time to implement it, or someone for performance reasons or perhaps less compelling reasons say, well, here is my C or C++ library, and we'll hook it into Python, has the same thing. You can call into C code as well as Go, obviously, and that's where your security boundary is possibly missing. So let's actually use that as the segue into one of the Black Hat's AppSec track. Presentations I was looking at is called the Devil's in the Dependencies, and this is from Veracode, and they're talking about their state of the open source software report. So one of the things that we've talked about here in the past, but one of the things I wanted to highlight here is that I think when the last time we talked about it, we didn't focus too much on how much the language choice affects some of the dependency or the flaws within library, or the flaw density within library dependencies, and I don't think I gave a really good enough appreciation to what they were talking about update chains, meaning I like to very glibly just say, well, just keep installing your point updates or your major or minor version updates with your semver. What they're highlighting is that even with updating, those updates may still have flaws, and it may take 1, 2, 3, 4, or maybe even 6 updates to get to the point where you've actually updated yourself to where there are no known vulnerabilities. So I thought that was a really good way to acknowledge that just saying update isn't always the easiest thing to say, because there are nuances that come with it. And they were also measuring what that update chain looks like, which is basically kind of, I think, a proxy metric to say how difficult is this going to be. So those are the two things that stood out for me.
Yeah, I mean, it's great research. I mean, Veracode has a lot of insight into this data. While Chris Eng was presenting this at Black Hat, I had Chris Weisselbull on doing a micro interview on Virtual Hacker Summer Camp. Veracode's done a lot of interesting expansion of their portfolio, but they've also got a lot of this great data. Look, JavaScript, Ruby, Java, PHP, they're still pretty high on the list. I mean, JavaScript, we know all the challenges with JavaScript, and these findings don't really change that.
No, they don't. I will say on the chains part, it kind of speaks to a little bit of the memory safety, kind of what John was alluding to, is that there are the short update chains in Go and Swift, for example, meaning that historically it's just been real quick update and you've been protected. These longer update chains where you need to get to a point where there's no known vulnerabilities tend to be longer for .NET, PHP, Python. So just kind of interesting how, some things to think about in terms of language choice. I think the only other thing that I thought to mention there was that in their notes, they saw cross-site scripting was in 30% of the vulns, and security misconfigurations was only less than 1% of what they've seen. And obviously, they even state this at the beginning, there's some selection bias, some observation bias, just about what code they're looking at or where they're looking. But it does, I do mention that in the sense of, always, as you're looking at these things, looking at vulns, keep that sense of what is the impact in mind, because the impact of misconfigurations, especially if we're talking like in the last segment with Terraform and infrastructure as code, that's going to be a lot more consequential than the what I'm going to typically just yawn at when I say cross-site scripting.
Yeah, and I think that's the important difference to recognize. Most of this is in the source code. Where you're going to find a lot more misconfigurations is in spinning up the infrastructure and the infrastructure configuration that could then lead to much more devastating attacks than maybe a source code misconfiguration. So I think it's also what they're sampling to understand where the misconfiguration really comes. And we've traditionally seen that in the misconfiguration of the infrastructure.
Yeah, and I think what we can do, we have a lot of articles this episode, which I think is great. And we have about 3 more flaws that we'll kind of jump into, because for me, they stand out once again to one of my, possibly my second favorite thing next to directory traversal, which is protocol analysis. So another thing that came out of Black Hat was some research about you have no idea who sent that email, which is basically some researchers who were looking at SPF, DKIM, and DMARC and saying, great, these are good security improvements that have been made to the protocol and with DNS to be able to say, with better attestation, who's allowed to send an email, what domain, what domain is going to attest that this email passed through my systems, and how can the recipient then both verify basically what I was just describing as SPF and DKIM. What they were showing is that there's a difference between what a protocol definition or what a standard describes and how that standard is implemented. And those implementation or impedance mismatches, is often the way I like to describe it, can come from lots of ambiguity on saying that, and as they were showing out, SPF is attesting to what the from address looks like from the hello command, whereas DMARC is looking at what's more the user-friendly, the mail from section of an email message. So it's just showing that with these small differences and ambiguities in both what the standards are saying, what they're supposed to be attesting to, as well as what the implementation of these security techniques or these security tools are looking at, once there's a mismatch between them, then it still may be possible to spoof messages, get phishing through, and so on. So for me, those stood out, one, because email, it's been around for a long time, and that there are still flaws to be found here. And two, I think these types of problems can generalize into the HTTP protocol as well as just web applications in general.
Which means we're going to see still a lot of email phishing attacks succeeding, I guess.
Phishing is not going away. We'll also see, well, hopefully not anymore because they've been fixed, but some LTE attacks. And here was another protocol analysis. In this case, some researchers were looking at LTE networks, and they came up with a good branding for this called ReVoLTE, which I thought was a very excellent pun on VoLTE. But basically what they were showing is, again, crypto issues. So that was one of the other parts I wanted to highlight this one for a theme of this particular episode. And if I can find the quote, was that, what did they say? One, they were demonstrating real world attack scenarios so that basically they could demonstrate that by protocol, a conversation between John and I, for example, should rekey itself if I were to hang up and then call him right back. But in practice, that they saw that the keys were being reused, and once you start to reuse keys or reuse IVs, these are some of the sins that come out of cryptography or use of encryption, and those suddenly weaken your crypto, your ciphertext, turn them back into plain text, which was a demonstrable attack here. Not something necessarily that could be pulled off at scale massively, but still great research and a great type of analysis of the difference between what should have been implemented and what was implemented in the real world.
I also did a really interesting segment around satellite communications at Virtual Hacker Summer Camp, kind of on this lines, right? There, though, because you're using Spectrum kind of TV signals, there are gaps in encryption capabilities when it comes to satellite communications. And there was some interesting research done out of the UK from one of the PhD students. So if you're interested in some of these interesting communication breakdowns, whether it's reuse of keys that are breaking encryption or even the potential lack of encryption in some of these communication mechanisms, we think so much about normal, like wired internet traffic, but there's these other networks that have different ways or issues with protecting communication.
No, that's great. I think one of the other things too, I highlighted in the show notes, and maybe we'll skip to, I think, some of the other articles instead, was another research from Woot, which was a workshop on offensive technologies, which was also from Usenix. So a lot of conferences are going on within August, and this was about the hardware security is hard, but basically saying that the boundaries between hardware, firmware, software tend to be a bit fuzzy, and that hardware, firmware, especially, I think, has some applicability to what you were just saying there about satellite communications and the devices, as well as just in general when we talk about supply chain. And that's one of the focuses. What this was highlighting is that firmware, who's signing the firmware, and if one actor is signing this area of it, another actor is signing the hardware, there may be some boundaries that are being crossed where those assumptions are maybe not correct, or that's where some security flaws can creep in. And I think maybe John, I don't know if there's something else you want to dive on here in terms of hardware, because I know that's near and dear to your heart, because that's also some of the articles you were highlighting about steps to avoiding these vulnerabilities more generally, Matt.
Yeah, well, it's interesting. We covered, so again, 2 weeks ago, we did an interview with Eclipsium on the boot hole attack, right? And one of the things that got really interesting in that conversation is we think about hardware, firmware, and software, but firmware is not as firm as we think it is. And we were actually joking about, is there another term? Because now firmware is updatable. It's not that firm anymore, but it's not all the way to software either. It kind of sits in between. And there's interesting challenges when it comes to these different hardware components, not only the signing side, but also the interdependencies of how some of these things work, like in the boot hole attack, for example. So it's a very interesting space that not a lot of people are paying attention to. Eclipsium and some of the other folks that are doing kind of firmware-based IoT research are really starting to see some interesting vulnerabilities that we've just kind of just assumed were okay. These components were okay for the longest time.
Yeah, it's tricky, right? Because some areas of firmware, you don't want that to be changed. So, off the top of my head, the ESP series, the 8266 and the 32, they've got a fuse in there that once you burn what you can, and I think most chips do, once you burn what you consider to be the firmware onto that chip, you're able to burn the fuse so that it can't be updated again. So it becomes write-only, right, or read-only. So some of these things can be fixed, but that's one of those bounces, is where do you draw that line between what do you think should be fixed, or what do you say, this is the last chance? And when you say this is the last chance, there's another, I was looking for it, I can't find it, whoops, sorry. There's another vulnerability came out in the last week or so in someone's firmware that I think is going to require a hardware replacement, or at least not an easy, there's no easy path to patch. So it's an interesting space, right? And really what's going on is, beside the researchers looking for new stuff in new areas, is that the bad guys are too. So as we start seeing more folks using TPMs or something like that to do hardware-based security, I think that boundary, there's two parts to that boundary. One is the boundary of the security people who have AppSec experience might not be the guys that are looking at the hardware side of things. So how does that boundary play into this as well, and make sure that you actually get good coverage on testing those things? So it's going to be an interesting year or two in that space, I think.
Yeah. Boot hole was a really good example of this, and the interdependencies of the secure boot with Grub. And the patch for this is not easy. It's very difficult. Any one piece that fails could literally brick your machine. This is some hardcore stuff here, no pun intended. But this is where some of these attacks are starting to shift, and they're very interesting. Some people aren't really paying attention to that attack vector.
Yeah, and I think with an AppSec hat on as well, there's definitely some very important domain expertise that's needed in here. One, just if, for example, talking about like the Go client, you could be very good at application security, saying we do need to encrypt things, write it up in Go, but if you don't have that crypto experience, you may miss the nuances of potential vulnerabilities you're introducing. In this case with firmware, firmware may not, in these embedded systems or hardware systems, may not not even support ASLR, or you may not be able to compile with something like ASLR. So some of your defensive tool chest, some tools might be taken out of it, as well as also you may be running in a much more constrained environment. So you don't have a full 64-bit address space, things like that you also may be able to have stricter. I just lost my train of thought there. But basically, constrained execution environment, those constraints can also make it harder to add security protection. So additional things where it's a lot more important to have that domain expertise of firmware and hardware to have that AppSec applied to it.
Yeah.
So I think, where was I going with that? Let's see. This was, sorry guys, just let you down. I just had no good segue from there, other than to say, what are some additional tips? Hopefully there's 3 of them for securing open source software. So the reason I was highlighting these particular, some of the flaws and the black hat information was that they're not talking about input validation. They're not talking about cross-site scripting. They're talking, we're looking at things that are more that don't easily fit into an OWASP top 10 or an OWASP mobile top 10 category, yet they're very obviously consequential. And so here is an article from Dark Reading that, Matt, you had highlighted that was talking about just some steps to take. And I do like that these things are talking about fundamental, basically, steps to put a DevOps, or call it a DevSecOps team onto a maturity path, rather than focused on something that's like very tactical in terms of use this tool or use this other tool.
Yeah, the reason I brought this article in is because I think it ties to the other article, which is the 4 best practices for open source, right? We see a lot of usage of open source. This whole grub issue with boot hole is an interesting example as well. Do people understand that grub is open source, that there are potentially vulnerabilities in it, and who's managing this, right? And so when you take these 2 articles together, it gives you a really interesting way to think about, how do I get my arms around this? The 3 tips of making sure you have secure software development, you're looking at trying to understand and manage risks, and then using some level of automation ties into this 4 best practices article that was linked right next to it, which is, look, I got to understand my software and all my dependencies that are sitting there, because this is where we see a lot of kind of blind vulnerabilities exploiting code and applications, is because, hey, I have this container and I've got a bunch of include files, and I don't understand the downstream impact of leveraging all those existing binaries and libraries. And so that creates this really, really huge attack surface and gap that people, they're kind of blind to, right? And then that goes into automatic code scanning to find the unknown unknowns, back to some of the automation. And then licensing was the last piece they brought in here, because there are also some really interesting potentially licensing risks in here. A little less on the radar screen for me right this second. I'm thinking more from the security vulnerability side.
Yeah, and I think this highlights too. I think at the beginning I said Veracode had their state of open source security. That was, I think, from Palo Alto. Veracode had state of software security report. But yeah, to really emphasize that point about resolving your, know your software, resolve those dependency issues. One of the other things that that they highlighted in their black hat is that some of these libraries, for example, the isArray library is literally like a 4-line long function that's your dependency. So there's also just as like, do you even know what dependencies you're pulling in, and do you need to be? Or what's the transitive dependencies? You may have said, oh, we know that we're pulling in this, but your libraries are also pulling in libraries. So suddenly you have this very complex, very busy dependency graph for your software. And if you can't tackle that, then the code you write may be secure. You might not have a great, SDL around the code that you're typing out on your own keyboard. But once you pull in someone else's, that dependency may weaken it right there.
Mm-hmm. And then you tied those 2 articles into the State of Application Security article, the ESG report. Holy cow. Now you understand why this is so difficult, people, right? And I've been saying this, and we've talked about this. According to the report, there's a variety of application security testing tools. No duh. There's how many markets here? It breaks out from this report. API security scanning, 56%. Infrastructure as code, 40%. Static analysis, 40%. Software composition analysis, 38%. Interactive testing, which we've talked about on the show a lot, 38%. Dynamic testing, 36%. Plugins for IDEs, 29%. Microservice scanning for containers, microservice 29%, fuzzing 16%, and container runtime 15%. That's the AppSec market in a nutshell. That's how many different sub-markets we're talking about to secure an application. It's super complex and super hard. So, where do I start? Do I start with APIs? Do I start with my binaries and libraries and my base source code? There is so much that has to be addressed in this space. I think it is challenging and looking for ways to streamline some of the tools and some of the processes that you're using to secure your code is important, but it's a big problem.
It is, and I think we don't have too. Go ahead, John.
I know we're in a short time. It's a good report. I've been trying to soak it in. Every page has all sorts of great stuff on it. It's the first link in the article is posted, so I highly recommend folks go and grab a copy.
Yeah, and I think we don't have time to get into it too much here, unfortunately, but what you were just saying there about how, you have to be really savvy about looking at the application security market and being smart where to, basically, you were saying, Matt, where to invest first, which is a bit of a callback to what John had introduced us when we were talking about Microsoft and bug bounty. When do you invest in bounties? When do you turn around and take that budget, assign it to some more builders or getting rid of a bug class? And that does touch on one other article that I highlighted here is about making your security team more business savvy, because while it is extremely important to figure out, do we start with API security, binary, looking at your binary, looking at your firmware, et cetera, you also have to understand what's going to be the impact of that on the business, on the product team, and what are the features or engineering constraints that they're under. So great article there. And I think, however, we won't have time for it to talk about it now, but you'll be able to pick it up later today.
Yeah, I'm going to cover aspects of this article on Business Security Weekly later today. So if you want to see the deep dive on that article, join us in a couple hours.
Awesome. Well, we definitely appreciate the deep dive that you and John gave us here on the many flaws that came out of summer camp, as well as other flaws that have been reported by researchers. And for those of you, again, one more reminder, if you haven't seen all the content that Security Weekly created for all of the virtual Hacker Summer Camp, go take a look. They're all on. You can find them all on the website, or come ask us in the Discord. And with that, just want to say once again, thank you all. Thank you for listening, and thank you for joining us. We'll see you again next week on Application Security Weekly.